Welcome to Ask and Learn.
For each of these series, let's determine whether the ratio test is inconclusive. So for part A, let's look at this one first. This will be our AN. So we'd like to look at the limit as n goes to infinity, absolute value, AN plus 1 over AN. So in our case, here's AN plus 1. And then we'll divide that by AN. Now let's go ahead and multiply out. This will give us n cubed over n plus 1 cubed. Now if you like, you could go ahead and use L'Hopital's rule. In any case, you'll get 1 when you evaluate this limit, and we know that the ratio test is inconclusive when the limit equals 1. Since our limit equals 1 in part A, we conclude that the ratio test is inconclusive for the first series. And now let's go on to part B. Now this is our AN. And we could even go ahead and do a little cancellation to write this as 1 over n. So I have the limit, n goes to infinity. Once again, AN plus 1 over AN. Now the numerator, this is 1 over n plus 1. And the denominator, 1 over n. Let's go ahead and flip that denominator and then multiply. Once again, you could use L'Hopital's rule here, and you'll get a limit of 1, just like in part A. And we conclude that the ratio test is inconclusive here as well. So that's for part B. Now let's go on to part C here. This is our AN. So once again, we start off with the usual limit in absolute value. AN plus 1 over AN. So I have n plus 1 minus 1 over radical n plus 1, and divide that by AN. So now notice that we can ignore the absolute value. If we remove the negative signs, we could drop the absolute value. So what I'll do here is just take this onto the next page so I could have some more room. So we're still on part C. So we'll have 3 to the n over radical n plus 1, and then radical n over 3 to the n minus 1. So go ahead and cancel as many 3's as you can. You could cross off n minus 1. You'll still have 1 3 up top. And then this limit over here will go to 1. So this limit becomes 3, which is bigger than 1. So series C diverges. And in particular, we see that the ratio test is not inconclusive here. That's for part C. So that's the first one that we've come across to where the ratio test was not inconclusive. And let's see what part D says. So this series was from 1 to infinity. Radical n, 1 plus n squared in the bottom. So now we look at the limit an plus 1 over an. So let's start writing this out. So here's my an plus 1. And divide that by an. So as usual, we'll go ahead and take that second fraction and flip it upside down and multiply it. And we can verify that both of these limits are 1. So for the first fraction, if it helps, you can rewrite this as n plus 1 over n, 1 plus 1 over n. And when you take the limit, that goes to 1 plus 0 in the radical, which is just radical 1 equals 1. And similarly, for the second fraction, you can divide by n squared or use L'Hopital's rule, but this limit will also go to 1. So we conclude that the limit goes to 1, and so that the ratio test is inconclusive for part D.